Welcome to saitechinfo channel, my dear students. In this tutorial, I will be explaining about the escape speed and the problem based on this escape speed. Let us look into this problem. The escape speed of a projectile. Escape speed of a projectile on the Earth's surface is 11.2 km per second. So let me put V escape is equal to 11.2 km per second. So this should be immediately converted into meter per second. So 11.2 into 10 power 3 meter per second. Your body is projected out thrice this speed. So let me say the projection velocity Vp is thrice the escape velocity. What is the speed of the body far away from Earth? Ignore the presence of Sun and other planets. So what is asked here? The speed of the body is asked. Now let me consider the mass of the projectile as m and the velocity of the projectile from the Earth is, let me say, Vp. So we will call it Vp. Right. We know the total energy of the projectile on the Earth is equal to, that is, half mv squared. Here half mvp squared because projectile minus half m v escape velocity squared. So this is something concerned with the kinetic energy. So the gravitational potential energy of the projectile, it is far away from the Earth, so it is a 0, right? Therefore the total energy of the projectile can be, that is, even though it is the kinetic energy and potential energy, here the potential energy is ignored, so we can take the total projectile energy, the total energy of the projectile far away from the Earth, that can be taken as half into m v p squared. Okay, right. Let me say, that is, we had to distinguish this because it is far away from the Earth. We will put V1, okay, because it is said far away from the Earth. Let me distinguish this by V1, so we can put V1 squared. Okay, right. Now the total energy of the projectile far away from the Earth is given by half into m v1 squared. Now from the law of conservation of energy, what is law of conservation of energy? That is, we have got this total energy, that is half m v p squared minus half m v escape velocity squared is equal to the projectile far from the Earth, projectile energy. So half, that is this one. Let me consider this as equation 1, this is equation 2. So these two can be equated. So half m and then v1 squared, right? And we can strike out half m in all these cases, half cancel, m cancel. Now we have v1 squared is equal to vp squared minus v escape velocity squared. Our objective is to find out v. So v is equal to the whole square root of vp squared minus v escape velocity squared, and we have got this relation, that is vp is equal to thrice the v escape. Therefore v is equal to, let me put here, v is equal to the whole square root of, and instead of vp we can introduce this equation. Therefore 3v escape squared, escape velocity squared, minus v escape velocity squared. So that is equal to 2v escape velocity squared, square root 2. Okay, and therefore it is nothing but, that is, it is thrice, is it not? So thrice of v squared means, that is, you have to put 3v escape squared, thrice you can put like this. So it becomes 9 actually. Okay, you have to be very careful. 3v escape whole squared, so 9v escape velocity squared minus v escape velocity squared. Therefore 8v escape velocity, right? And we can split this as a 2 into 4. So for 4 square root is 2. So you can put 2 and then root 2 v escape velocity squared, right? Now you can substitute and get the answer. So we have got already 11.2. So 2 into root 2 is nothing but 3.14. 3.4, I mean root 2, 1.4 and 4. 1.4 and 4 into, and this v escape velocity is nothing but, and this square can be removed, is it not? So you have to remove this square because square root 2. So we have got velocity, escape velocity, and that is 11.2. So the final answer is 31.68 kilometer per second, right? And you got 11.2 into 10 cube, so you can introduce 10 cube, and finally it can be converted into kilometer once again. Okay, so the final answer is this one. So this is the what? The velocity of the projectile. You understand? That is, it can, we have represented this as v1, so you can put the same. Okay, so let me summarize this problem. The escape speed of a projectile on the Earth's surface is 11.2 km per second. A body is projected out with thrice the speed. What is the speed of the body? Far from the Earth. So what are the important relations here? You have to work out the total energy using the kinetic energy of projectile and escape velocity. The net energy should be taken as total energy, and in other case total energy of the projectile far away from the Earth. So the gravitational energy, I mean the potential energy, gravitational potential energy is 0. Therefore we have to consider only the kinetic energy. So according to this, the total energy is this one. So we can compare these two equations and arrive at all these things. So removing the common terms, we are able to get the velocity v1. Actually this is v1. Okay, do you understand? Right, thank you for watching this video.